Under a velocity graph, the displacement is going to be the area under that function. So the area is the displacement of the object equals the area under the velocity function. Now we're going to give this a name. These are going to be called Riemann sums. So these rectangles are Riemann sums. So these are the areas. So in this graph here, we have a nonlinear function for velocity, and we're going to calculate the displacement by using interval widths of 2 seconds or rectangles that are two units wide. So I've kind of sketched in the rectangles here. The area underneath here, these areas are going to represent our displacements. And we're going to use the rectangular area calculation to estimate these displacements here. So this area in here, this area that I'm shading in, that represents our displacement. So estimating the height of each of these rectangles, it looks like the first rectangle is about 1 high or 1 meters per second. For 2 seconds, we're going to have an area of 2 meters. The second rectangle we'll say is about 2.5 high, and it's for 2 seconds. So we're going to say 2.5 meters per second high times 2 seconds is going to give us 5 meters of displacement. Okay, so we're going to write that in. For the next one, same thing, it's the same rectangle. For the third one, for the fourth rectangle, it looks like it's 6 meters per second high. For 2 seconds, that's 12 meters of displacement. And then for the last one, it looks like it's 12 meters per second high for 2 seconds. So that's going to be 24 meters of displacement. So find the total area, which is equivalent to the total displacement. We're going to get 2 plus 5 plus 5 is 12, plus 12 is 24, plus 24 is 48 meters of total displacement. Now, we talked about the little bit of mismatch with the actual area and the missing area. These little bits of missing area in here. Okay, those do represent the real displacement. To get that, what we can do is we can use smaller and smaller intervals. So if I drew in rectangles of smaller intervals, those gaps become less and less. So this is a key idea. So it doesn't matter where we measure the shapes or what kind of shapes we use. As long as we make those rectangles thinner, we're gonna get better and better estimates. Now, we could use, in this case, we used the left edge height. So the left edge, so I'm just gonna point this out here. The left edge was where we measured the height. We could have actually measured height at the middle of the interval. Okay, so these are all left edge heights that I use, but we could have actually used the height at that point in the middle. Okay, and that would be a different, or we could use the right edge of that interval height. Now, again, regardless of where we measure that or the different shapes that we're going to end up using, we're going to end up using trapezoids eventually. It doesn't matter what shape we use, where we measure it, the key idea is, as long as we make those rectangles narrower or thinner, we're going to get better and better estimates of the actual displacement or the actual area under the curve.